Hello there and welcome back to the sleep science documentary Space, where you get to drift through the big, slightly terrifying questions of existence in a way that somehow helps you unwind. Tonight, your eyes float across the great curve of the Earth as if you've just risen above the atmosphere. Below you is that fragile blue marble, glowing with oceans that shimmer like glass under the morning sun. Swirls of white cloud trace spirals across the Pacific, and deep green continents peek through in patches, the very picture of stability and beauty. From up here it feels unshakable, like this planet could last forever. But you and I both know better. Earth has been around for 4.5 billion years, and it has already nearly destroyed life more times than anyone cares to count. The brutal truth, whispered softly so it doesn't sting too hard, is this: someday this beautiful marble won't be livable anymore. You probably won't survive that long, but hey, at least that means you don't need to start panic packing an interstellar suitcase tonight. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. I'd love it if you also commented your location and the time where you're listening from. It's always strangely comforting to know this sleepy little community is scattered across the globe, each of you tuning in from your own corner of the planet. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. Your journey begins by floating in orbit, gazing at the thinness of that shimmering atmosphere hugging Earth's surface. Astronauts often say the most shocking thing about seeing Earth from space is realizing how small and delicate it looks. The oceans, continents, storms, all of it seems wrapped in nothing more than a thin bubble, and that bubble is exactly what makes life possible. Without it, you wouldn't have oxygen to breathe, liquid water to drink, or that perfect balance of temperature that keeps things in a cozy Goldilocks zone. You might think Earth is a fortress, but really it's more like a glass snow globe balanced on the edge of a table, where the universe sometimes bumps past. The ancient Greeks, looking up from their sun-soaked shores, were among the first to imagine Earth as a sphere floating in nothing. They weren't right about everything. Some of them thought the sun was a fiery chariot which, admittedly, makes traffic jams seem tame in comparison, but they were closer to the truth than they knew. Historians still argue whether early thinkers like Pythagoras really believed in a round Earth, or whether that idea got retrofitted onto him by later generations, but either way, the notion that our home is finite and round has always carried a certain existential weight. When you know the planet has edges, it suddenly feels like it has limits too. You descend back into the atmosphere and suddenly the sounds change. The silent vacuum gives way to the soft roar of winds brushing past mountains, waves slapping coasts and forests humming with life. This is Earth at its most alive, but even here on the surface you feel the fragility. Think about it. The breathable air around you is only a few kilometers thick. If Earth were shrunk down to the size of an apple, the atmosphere would be thinner than its skin. One peel away, and all life would suffocate. A comforting thought to fall asleep to, right? Don't worry, it gets worse later. Now you stroll across a dawn-lit plain. The grass bends with the breeze, and dew clings to each blade like glitter. Birds call lazily as if they don't realize they're living on borrowed time. You crouch, scoop a handful of dirt, and realize that even the soil under your fingernails is a product of violent cosmic accidents, asteroid strikes that delivered water, volcanoes that belched minerals, and ancient plants that decomposed into the dark richness. Every breath you take right now is thanks to billions of years of chaotic, sometimes catastrophic chance. Earth is beautiful, yes, but it is also wildly improbable. You pause to consider another fact. For most of its history, Earth was utterly uninhabitable for anything like us. The first billion years, a toxic, boiling mess. Oceans may have been acidic, skies heavy with methane. If you stepped out of a time machine, your lungs would burn, your skin would bubble, and you wouldn't even get the consolation prize of dinosaurs to gawk at. And yet, somehow, life clawed its way into being. Microbes thrived in hot vents and shallow seas, laying the groundwork for every bird, every tree, every awkward human dance move to come. If Earth could be that harsh for so long, it's not much of a stretch to think it could become that way again. Drifting further through thought, you remember how every culture has imagined an end of days. The Norse pictured Ragnarok, frost giants and fire consuming the world until only darkness remained. Ancient Mesopotamians told tales of floods wiping away humanity. Even the Mayans, despite popular 2012 doomsday memes, had more complex cycles of rebirth and collapse woven into their calendars. These myths weren't just melodrama. They were reflections of people looking around at floods, droughts, famines, and realizing that Earth could turn hostile with little warning. The stories were less about cosmic prophecy and more about survival anxiety dressed up in poetry. You climb higher into the sky again, watching city lights blink awake below. From this vantage, the planet looks calm, but you know the truth. The storms that hammer the Gulf, the earthquakes that shake Asia, the wildfires that rage in Australia. These are reminders that Earth is not a static paradise. It's a restless, shifting, sometimes downright cranky home. The joke's on us for assuming the landlord wouldn't raise the rent eventually. Still, there's comfort in continuity. For 4 billion years, Earth has held on to some form of life. Through asteroid strikes, supervolcanoes, ice ages, and even the time oxygen itself almost poisoned everything alive, the planet has always reset, recalibrated, and tried again. If you listen closely, you can almost hear it breathing beneath your feet. A planetary rhythm that whispers, not forever, but for now. And so you drift, caught between awe and unease, watching this planet spin beneath your toes. It's stunning, it's improbable, and it is temporary, which makes every moment you stand here, inhaling this fragile air, all the more miraculous. You're not just a bystander, you're living inside a window of habitability so rare it might not exist anywhere else within trillions of kilometers. Enjoy the irony. Your bedtime story is also a survival reminder. You step gently away from the surface and imagine yourself sinking, not into the oceans this time, but down through the very crust of the planet, into the hidden furnace at its core. The ground that felt so solid beneath your feet a moment ago becomes suddenly transparent, like a layered cake of rock and molten metal. Each step downward takes you deeper in time, deeper in temperature, and deeper into the reminder that this place you call home is never truly still. The earth rumbles and flexes, always reshaping itself, sometimes softly and sometimes with catastrophic flair. Beneath the calm meadows and suburban driveways lies a restless engine that has the final say over whether Earth stays habitable. You pause inside the mantle, where molten rock oozes and convects like slow honey, although the temperature is so high it could incinerate anything recognizable. From this invisible ocean of magma, continents are slowly carried around like rafts on a simmering stew. That gentle drifting is what gave us the Himalayas, shoved skyward when India slammed into Asia. Historians still argue whether ancient civilizations like the Harappans collapsed, mainly because of shifts in rivers tied to tectonic changes, or because of human choices in farming and trade. Either way, the lesson is the same. When the earth moves, societies stumble. Now you imagine the sudden violence of earthquakes. Somewhere, tectonic plates grind against each other like two stubborn neighbours refusing to compromise on fence placement. The tension builds silently for centuries, then releases in seconds, unleashing a quake that rattles cities, topples monuments, and rewrites maps. You drift over the ruins of Pompeii, where Mount Vesuvius proved in 79 CE that volcanic tempers can erase an entire community in an afternoon. The eerie plaster casts of people frozen in their last moments are not only tragic, they're reminders that the Earth is perfectly capable of evicting us with little warning. And yet, there's a quirky side to this violence. Did you know that Cleopatra's famous palace in Alexandria is now underwater, thanks to earthquakes and shifting ground? Somewhere under the Mediterranean, divers still explore those submerged marble columns, a kind of lost and found box of history created by Earth's own tectonic fidgets. The ground is not permanent, no matter how much we like to think of it as reliable foundation. It shifts, sinks, and sometimes swallows whole cities. You descend further until you reach the outer core, a sea of molten iron, swirling in currents that generate Earth's magnetic field. Without this shield, solar winds would strip the atmosphere away, leaving Earth as barren as Mars. The very thing that allows compasses to point north is also the planet's invisible armour. But even here there is instability. The magnetic field has flipped in the past, north becoming south and south becoming north, sometimes many times in a million years. Scientists debate whether such flips might weaken the shield enough to expose us to dangerous radiation. They agree on one thing, though: the core will never stop churning, and its moods shape life above in ways you rarely notice. Heat rises, pressure crushes, and you finally touch the inner core, solid despite temperatures hotter than the surface of the sun. This glowing sphere of iron grows slowly as the planet cools, inch by inch over eons. You think of it like a heartbeat. Each pulse outward helps sustain the magnetism that protects Earth, but each expansion also marks the planet's gradual cooling, a ticking geological clock. Someday, when the core cools too much, Earth's engine may sputter out. Without convection, no magnetic field. Without a field, no atmosphere. Without atmosphere, well, you'd need more than sunscreen and a hat to cope. As you rise back upward, you pass through scars left by ancient cataclysms. One of the largest known volcanic eruptions occurred about 74,000 years ago at Mount Toba in Indonesia. Some scientists believe it blanketed the Earth in ash and caused a volcanic winter that nearly wiped out early human populations, shrinking us to perhaps only a few thousand survivors. Others think the effects may have been less apocalyptic. Historians still argue whether Toba was a near doomsday or just a really bad camping trip gone global. Either way, the event shows just how thin the line between survival and extinction can be when Earth's engine flares. Closer to the surface again, you walk across Iceland's black volcanic sands, steam rising from fissures as though the planet is exhaling through its pores. Tourists soak happily in hot springs, blissfully ignoring the fact that those soothing waters are heated by the same forces that can split the ground wide open. A reminder that humans are experts at pretending danger is just a nice spa feature when it suits us. One minute you're sipping mineral water, the next you're running from lava. At least it makes for dramatic postcards. Everywhere you look, evidence piles up. Mountains uplifted, valleys torn, islands born out of undersea eruptions. The continents you know now won't last. Millions of years from now, they'll be rearranged again, colliding into a new supercontinent with climates so extreme that survival might be impossible for complex life. But in this moment, it's easy to forget. You sit on a warm rock, feeling its solidity under your palms, knowing full well it's a temporary gift from a planet that's always on the move. When you close your eyes, the rumble beneath you almost sounds like a lullaby, a reminder that Earth is alive, even if its way of expressing that life sometimes looks like destruction. The ground holds you tonight, steady enough to let you sleep, even as it secretly drifts on molten tides. You realize you're lying not on a stable stage, but on the lid of a restless furnace that will sooner or later demand payment for its hospitality. You rise again, drifting gently from the trembling crust into the open air above. The weight of rock and magma falls away, replaced by the light touch of wind. You tilt your head upward, and there it is. Earth's atmosphere, the thinnest veil, a shimmering cloak that looks like nothing yet does everything. From the ground it feels infinite. You look up and see endless sky, but from space it's barely a wisp, thinner than the fog on your bathroom mirror after a hot shower. And yet this translucent blanket is all that keeps the planet from becoming just another lifeless rock orbiting the sun. The first thing you notice is the layering. Down low, in the troposphere, clouds huddle and weather stirs. This is the layer where every storm, drizzle, rainbow and lightning bolt plays out. Rise a little higher and you reach the stratosphere, the realm of sleek jetliners and the ozone shield, which blocks the sun's ultraviolet tantrums. Higher still is the mesosphere, where meteors burn like fleeting fireflies, sparing Earth from being pummeled daily. Above that, the thermosphere glows with auroras, those hypnotic curtains of green and pink, as if the sky is trying to show off a bit before fading into the black. And finally, the exosphere, where air thins so much it stops behaving like air at all, blurring into the vacuum of space. Each layer a filter, each one fragile, together forming a delicate defense system. As you breathe in, you become aware of the strange balance of gases filling your lungs. About 78% nitrogen, 21% oxygen, a sprinkle of argon, and trace amounts of carbon dioxide and other odds and ends. It doesn't sound like much, but it's the perfect cocktail. If oxygen were just a bit more abundant, fires would rage uncontrollably, even your birthday candles might go nuclear. If it were much less, you'd be gasping, unable to jog across the room without fainting. Funny how an invisible balance you never think about is the difference between thriving and choking. You pause on a mountain ridge, the air thinning around you. Climbers on Everest know this struggle intimately. At the summit, the oxygen levels are so low, that many people need bottled air just to stay alive for a few minutes. That's still inside the atmosphere, inside the safe bubble. Step outside entirely, and you wouldn't last long enough to finish a goodnight yawn. Your saliva would boil, your lungs would collapse, and your final thought might be, well, this escalated quickly. Long before you arrived here, humans had already noticed the importance of this airy shield. The ancient Egyptians, for instance, believed air was one of the prime elements of creation. They tied their very concept of the soul to breath, the ka, that vital essence leaving the body at death with the final exhale. Across the world, cultures linked breath with life, often without realizing how scientifically accurate that was. Without this blend of gases, there would be no life, no soul, no sleepy YouTube documentaries about the end of the world. And yet, the atmosphere is no permanent guarantee. Historians still argue whether climate swings in Earth's past were primarily driven by volcanic outbursts, orbital wobbles, or subtle chemical shifts in the air. What's certain is that the air has been far less stable than it feels tonight. Go back 250 million years to the Permian-Triassic extinction, and you'd find carbon dioxide flooding the atmosphere, temperatures soaring, and 90% of species vanishing. Go back just a few hundred million years further, and the air might suffocate you with too much carbon dioxide and too little oxygen. The point is, Earth has often been inhospitable, and the current sweet spot is a rare, temporary grace note. Here's a quirky tidbit. In the 18th century, when scientists first started experimenting with gases, they gave oxygen a very different name: dephlogisticated air. Imagine trying to breathe while saying that out loud. Joseph Priestley, one of the early discoverers, reportedly tested it by putting a mouse inside a jar filled with the gas. The mouse lived happily, which must have been a relief for both the scientist and the rodent. Little did they know, oxygen's abundance in the air is not just luck, but the direct handiwork of ancient cyanobacteria that changed the planet forever. We'll come back to them soon, but for now, just remember, you owe every peaceful inhale to microscopic creatures who had no idea what they were setting in motion. As you float along, you glance at the ozone layer, that thin blue haze tucked into the stratosphere. For much of the 20th century, humans poked holes in it with chemicals like chlorofluorocarbons, the same stuff once found in hairspray and refrigerator coolants. Imagine, the very things keeping your bangs stiff in the 1980s were also letting ultraviolet radiation fry the planet. Luckily, people noticed, freaked out, and signed the Montreal Protocol in 1987, agreeing to phase out the worst chemicals. It actually worked. The ozone hole has been slowly healing. Proof that sometimes, when we notice our mistakes in time, Earth gives us a second chance. You close your eyes and listen. The atmosphere whispers with jet streams, carrying weather from continent to continent. It rumbles with thunder and sighs with trade winds. It glows at night with the shimmer of auroras. It is restless, protective, fragile. And though you can't see it, you feel it cradle you in every breath. Without it, no oceans would stay liquid, no plants would grow, no people would stay alive long enough to ask whether Earth will become uninhabitable. The atmosphere is both shield and gift, and also, like every part of this planet, temporary. You sink back toward the surface, passing through clouds so close you can taste the moisture. Raindrops cling to your skin, cool and fleeting. They remind you that water cycles through this sky endlessly, evaporating, condensing, raining down, repeating across billions of years. The same water molecules drifting here tonight may once have fallen on Cleopatra's palace before it slid underwater, or on mammoths grazing where Siberian permafrost now rests. Even the clouds carry memory, even the air remembers, and all of it is balanced, poised, almost impossibly delicate. One gust of change, one chemical imbalance, and the gift could vanish. You look up one more time at that infinite-seeming blue and whisper the truth to yourself. The atmosphere is not infinite, not unbreakable, and not forever. But tonight, at least, it still wraps around you like the softest blanket. The sky begins to brighten as you tilt your face toward the sun, that warm disk of gold that feels eternal and dependable. Every morning it rises and every evening it sets, like clockwork, like a promise. But beneath that reliable rhythm is a star that doesn't always behave. The truth is, Earth's habitability is chained directly to the sun's moods, and like any old celebrity with a lot of power, Those moods can swing from gentle glow to furious outburst. You bask in the warmth for now, but you can't help but think, what happens when the sun changes the rules? You let yourself drift through rays of light, each photon carrying energy across 93 million miles just to strike your cheek. It's a miracle of timing and distance. Too far away, and Earth would be an icy wasteland like Mars. Too close, and oceans would boil like a forgotten pot of noodles. Right now, Earth sits in the so-called habitable zone, the sweet spot. But the habitable zone isn't permanent. It shifts as the sun evolves. Already, scientists know the sun is slowly brightening over geological time. That means that in 1 billion years or so, even without human interference, the Earth may be too hot for liquid water. Comforting, right? You'll be dust long before then, but the planet you love won't escape forever. You remember that ancient cultures often worshipped the sun, sensing instinctively that life depended on it. The Egyptians honoured Ra, the god who sailed across the sky in a flaming boat. The Aztecs believed the sun needed sacrifices to rise each day, an energy exchange of cosmic scale. And though these stories might sound dramatic, they were rooted in a clear truth: no sun, no life. Historians still argue whether early solar deities reflected agricultural necessity more than cosmic awe. But the fact remains, our ancestors feared losing this daily fire. They weren't wrong to worry. The sun is far from a calm lamp in the sky. It seethes and boils, a ball of plasma powered by nuclear fusion. Every now and then, it erupts in solar flares and coronal mass ejections, sending out storms of charged particles. Most of the time, Earth's magnetic field deflects them, giving us the northern lights as a dazzling side effect. But sometimes, the storms are stronger. In 1859, a massive solar event called the Carrington Event struck Earth. Telegraph lines sparked and burned, operators got shocked, and auroras lit up the sky as far south as the Caribbean. If something like that happened today, it could fry satellites, knock out power grids, and send your phone back to the Stone Age. Imagine explaining to future archaeologists that our civilization collapsed because TikTok stopped working. A quirky but true tidbit. In 1972, during the Vietnam War, a solar storm was so strong it detonated US naval mines off the coast. Imagine being the officer writing that report. Dear Command, the sun blew up our weapons. No, really. The point is, the star you think of as a steady friend is fully capable of lashing out with deadly force. You drift further out and look back. Earth shines in the sun's light, delicate, vulnerable. For most of the planet's history, solar cycles have driven ice ages and warm spells, sometimes nudging life toward extinction, other times giving it room to flourish. Historians still debate whether the Little Ice Age between the 14th and 19th centuries was primarily caused by a lull in solar activity, known as the Maunder Minimum, or by volcanic eruptions that filled the sky with dust. Either way, the sun's variability had consequences. Crops failed, rivers froze, and desperate people in Europe held frost fairs on the frozen Thames, making the best of a colder world. But the deeper fear isn't a temporary chill or flare. It's the long arc of stellar evolution. The sun, like all stars, has a life cycle. Right now, it's in its comfortable middle age, burning hydrogen into helium steadily. But eventually, billions of years from now, the hydrogen will run low, the core will contract, the outer layers will expand, and the sun will swell into a red giant, engulfing Mercury, Venus, and very likely Earth. Our oceans will boil, the atmosphere will strip away, and the surface will turn into a scorched wasteland. It won't be a gentle fade-out, it will be a fiery eviction notice written across the sky. For perspective, the sun is about halfway through its 10 billion year lifespan. That means Earth still has time, billions of years in fact. But time in cosmic scales is tricky. To the dinosaurs 65 million years ago, it probably seemed like the sun would shine forever too. You realise that habitability isn't just about where Earth is now, but about where the sun is going. You and your planet are tied to a star that doesn't promise eternity. You imagine the final scene, Earth's atmosphere ripped away, oceans steaming into space, surface glowing red under a swollen sun. Long before that moment, life as you know it will be gone, either by human mishap or by the sun's slow brightening. A grim bedtime story, sure, but oddly freeing, because if the sun itself is temporary, then Earth's fragility is part of a much bigger pattern. The universe doesn't owe permanence, it only offers moments, and you happen to be living in one of the rarest, most comfortable moments of all. For now, though, the sunlight warms your face, you can hear wind moving across forests, waves crashing against cliffs, and laughter drifting from cities below. The sun still rises, the air is still breathable, and your bed is still soft. You hold on to that, aware of the ticking clock but grateful for the present glow. You step softly into the past, farther back than pyramids, farther back than dinosaurs, even farther back than the first multicellular creatures that dared to wiggle. The Earth is unrecognizable. No trees, no animals, not even the comforting blue sky you've grown accustomed to. The air is thick with gases that would choke you in an instant. Carbon dioxide, methane, and nitrogen swirling together like the world's worst soup. You stumble through a swampy shoreline, holding your breath, wondering how life could possibly have survived in this suffocating mess. And yet, as you peer closer, you find the unlikely heroes of this story. Tiny microbes, invisible to the naked eye, quietly rewriting the planet's destiny. These little architects are cyanobacteria, though you might know them by their less glamorous nickname, blue-green algae. Billions of years ago, they began performing photosynthesis, using sunlight to split water molecules and releasing oxygen as a byproduct. At first, it didn't matter. The oxygen was absorbed by iron in the oceans, staining them rusty red. But eventually the gases began to accumulate in the atmosphere. You inhale now, filling your lungs with that 21% oxygen mixture because of their tireless work. You owe every single breath to microbes that lived and died long before you were even a dream of evolution. This period is known as the Great Oxidation Event, around 2.4 billion years ago. It sounds grand, almost celebratory, but for many organisms alive at the time it was a nightmare. Oxygen for them was toxic. Imagine being poisoned by fresh air. Entire ecosystems collapsed, countless species wiped out, victims of a gas that you now depend on. Historians still argue whether oxygen built up quickly, in catastrophic bursts, or slowly, with stop-and-start surges across millions of years. Either way, the irony is undeniable. The same element that allowed complex life to evolve was once a death sentence. You sit at the edge of a shallow, ancient sea, watching bubbles of oxygen rise from mats of cyanobacteria. They shimmer like tiny silver balloons floating to the surface, bursting into a sky that doesn't yet know what it's becoming. It looks peaceful, almost charming. But you realize this was one of the most radical revolutions in Earth's history, perhaps the greatest environmental catastrophe ever, depending on whose perspective you take. For early anaerobic life, this was the apocalypse. For you, it was the opening act. A quirky tidbit comes to mind. Some modern scientists have experimented with oxygen bars, where people pay money to breathe concentrated O2 for a supposed energy boost. Ironically, breathing too much pure oxygen can damage your lungs, ignite fires, and cause dizziness. In other words, humans today willingly do to themselves what ancient microbes once suffered unwillingly, overdosing on oxygen. Life, it seems, has a talent for repeating questionable decisions. Fast forward through deep time, and oxygen's role keeps shifting. Around 600 million years ago, levels rose high enough to support the first complex animals. With oxygen fueling metabolism, creatures could grow larger, move faster, and eventually crawl onto land. You walk beside the shadow of a trilobite scuttling across the seafloor, its every twitch made possible by those ancient oxygen bubbles. Without them, there'd be no trees, no fish, no cats knocking glasses off counters, no humans telling bedtime documentaries about planetary doom. Still, the balance has always been precarious. Too little oxygen, and large animals can't survive. Too much, and fire becomes uncontrollable. Imagine a forest where even a small spark turns into a planet-wide inferno. In fact, during the Carboniferous period, about 300 million years ago, oxygen levels reached around 35%, compared to today's 21%. Insects grew to terrifying sizes, dragonflies with wingspans as wide as a hawk soared over swampy forests. Historians still argue whether oxygen alone caused these mega insects, or whether other environmental factors played a role, but the correlation is uncanny. If you hate mosquitoes now, be grateful you weren't around when they were practically the size of frisbees. You lean back and glance at the present sky. realizing that this invisible gas is still the razor's edge of habitability. If humans pump too much carbon dioxide into the atmosphere, it disrupts not just temperature but also oxygen regulation, ocean chemistry, and the delicate breathing rhythm of the biosphere. And though modern plants continue the legacy of cyanobacteria, they may not always keep up with what we're doing. The planet's breathing could become ragged, strained, or in the worst case, silenced. It's humbling to know that the air you trust so casually, the inhale before sleep, the exhale into a sigh, was an accident of microbial chemistry. No grand plan, no guiding hand, just a bunch of tiny organisms that happened to discover a new way to use sunlight. You imagine them like clueless inventors tinkering in a cosmic garage, unaware that they were creating the conditions for future forests, cities, and civilizations. The fact that oxygen can both give life and take it away is a reminder that habitability is never fixed. It's negotiated constantly between life and the environment. You sit quietly on the shore of that ancient ocean, listening to the fizz of oxygen bubbles rising all around you. It almost sounds like soda being poured into a glass, tiny, cheerful, and unassuming. But those bubbles carry the weight of everything to come. They are the whispers of possibility, the beginnings of lungs, of fire, of words, of you. And if oxygen could so easily shift from poison to salvation, it reminds you that Earth's balance can shift again. The very air you trust may not always be safe. But tonight at least, you can take a long, slow breath, grateful for those microbial ancestors who unintentionally gave you this moment of calm. The ground under your feet crunches with gravel as you wander into a fossil plain, a place where deep time is written in stone. All around you, slabs of rock hold the imprints of creatures that lived, thrived, and then abruptly disappeared. It's quiet now, just the wind brushing over eroded cliffs. But if you listen closely enough, you can almost hear echoes of oceans drying, forests collapsing and skies darkening. The story of Earth's past is also a story of sudden endings, of mass extinctions that nearly erase the page altogether. And the uncomfortable truth is this: extinction has been the rule, not the exception. You're just lucky enough to be living during one of the rare calm intermissions. Paleontologists speak of the Big Five mass extinctions, 5 colossal die-offs when at least 3/4 of species vanished. The first came about 445 million years ago, during the Ordovician period. Much of Earth's life still clung to the oceans then, and sudden ice ages followed by rapid warming wiped out nearly all marine creatures. You crouch by the imprint of a trilobite, its delicate shell frozen in stone, one of countless victims of shifting seas. Historians still argue whether glaciation alone caused the collapse, or whether asteroid impacts and volcanic outbursts piled on. Either way, it was the first great reminder that Earth is not sentimental about its tenants. You walk onward and stumble into the Devonian extinction, about 375 million years ago. This one especially targeted fish. Entire lineages wiped out as oxygen levels in the seas plummeted. Forests may have played a role, oddly enough. As the first trees spread across continents, their roots and decay altered the chemistry of rivers and oceans, sucking oxygen out of the water. Life on land thrived, but for marine species it was suffocation on a planetary scale. A quirky fact: some of the earliest amphibians, creatures that could gulp air and crawl onto land, may have survived precisely because they weren't dependent on drowning seas. In other words, lungs may have been the ultimate insurance policy. The most infamous of all is the Permian-Triassic extinction, around 252 million years ago, often nicknamed the Great Dying. Over 90% of marine species and 70% of land species vanished. You stand in the shadow of giant volcanic fissures in what is now Siberia, where eruptions poured lava and belched gases for hundreds of thousands of years. The sky would have been choked with ash, oceans poisoned with carbon dioxide, climate spiraling into chaos. Imagine entire forests collapsing into silence, deserts spreading across continents, and seas turning into acidic soup. Historians still debate the exact chain of events: volcanism, methane bursts, asteroid impacts, but the outcome was clear. Earth very nearly pressed the reset button on complex life. If you're feeling cozy in bed right now, just be glad you weren't trying to nap through that apocalypse. You step further into time and find yourself in the late Triassic, about 201 million years ago. Dinosaurs were just getting started, but volcanic rifts tore open the Atlantic and altered climate patterns. Again, massive die-offs, clearing ecological space for dinosaurs to dominate for the next 135 million years. And then, of course, comes the one you already know, the Cretaceous-Paleogene extinction, about 66 million years ago. A 6-mile-wide asteroid slammed into what is now the Yucatan Peninsula, unleashing tsunamis, wildfires, and a global impact winter that blotted out sunlight. Goodbye, non-avian dinosaurs. Hello, mammals. Without that rock from the sky, you wouldn't be here. A reminder that even catastrophes can sometimes open doors for the survivors. Amid all this destruction, you notice something strange. Life always found a way back. After the Permian extinction, new lineages emerged. After the asteroid strike, mammals diversified. Extinction events were brutal, but they were also turning points, clearing the ecological stage for something new. It doesn't make the losses less tragic. You can almost hear the silence of vanished species, but it does reveal Earth's odd resilience. Catastrophe, then renewal, then catastrophe again. A cycle both terrifying and strangely comforting. One fringe tidbit you might not expect. In the 19th century, some scientists believed ammonites, spiral-shelled creatures that disappeared during the last mass extinction, might still survive in unexplored oceans, lurking like prehistoric holdouts. The idea hasn't held up, but it speaks to our unwillingness to accept that entire lineages can vanish forever. We like to think Earth has secret hideouts for the things we've lost. Sadly, fossils whisper otherwise. Standing among these graves of deep time, you realize that extinction is not a distant threat. Scientists argue whether we're now living through a 6th mass extinction, this one caused by humans. Species are disappearing at rates far faster than background levels, driven by habitat loss, pollution, and climate change. You wonder if future fossil hunters, alien or otherwise, will look back on this moment as another sharp line in the record. Another page torn from life's book. And yet, there's a strange peace in acknowledging extinction's inevitability. The trilobite didn't know it was doomed. The ammonite never saw the asteroid coming. You too walk a planet that offers no guarantees. But that also makes your present moment, breathing air, hearing birds, even listening to sleepy science ramblings, profoundly rare. In the silence of this fossil plain, extinction doesn't sound like a horror story. It sounds like perspective. You drift upward from the fossil beds, out of the silence of vanished worlds, and suddenly the ground beneath you begins to glow. Not from magma this time, but from electric grids and neon lights. It's night on modern Earth, and the human footprint is unmistakable. Cities sparkle like constellations, sprawling across continents, visible from space as a new kind of artificial starfield. From the Great Wall of China to the Las Vegas Strip, our species has left a signature as obvious as a tattoo on the planet's skin. For the first time in Earth's 4.5 billion year history, one species is changing the climate, atmosphere and ecosystems faster than most natural catastrophes ever managed. You hover above it all, caught between admiration for human ingenuity and unease at its consequences. You drift lower into the haze over a metropolis. The air feels thick, tinged with smoke, exhaust and industrial dust. Cars move like glowing veins, pumping carbon dioxide into the atmosphere with every commute. You don't need a volcanically active Siberian plateau to alter the climate anymore, just billions of people driving to work. Since the Industrial Revolution, carbon dioxide levels have soared from about 280 parts per million to over 420. It sounds like a small number, but it's enough to shift weather patterns, melt glaciers, and lift sea levels inch by inch. Historians still argue whether future textbooks will name this epoch the Anthropocene, a formal recognition that humans, not geology, are now the dominant planetary force. The debate is ongoing, but the evidence glows right here in the smoggy skyline. As you move through the streets, you see another footprint: plastic. It clogs rivers, drifts through oceans, and even falls from the sky as microscopic dust. A quirky fact: scientists have found microplastics in human lungs, in placentas, even in Antarctic snow. Imagine explaining that to Aristotle. Yes, great philosopher, we turned ancient sunlight into grocery bags and somehow sprinkled them across the poles. Humanity's legacy might not be pyramids or smartphones, but a thin layer of plastic and chicken bones preserved in the rocks of tomorrow. The landscape shifts and you glide over farmlands, endless grids of fields carved into rectangles. Agriculture, humanity's proud invention, also reshaped ecosystems into monocultures. Forests that once teemed with species have been replaced by corn, soy and wheat stretching to the horizon. Fertilizers spill into rivers, creating oxygen-starved dead zones in oceans. If cyanobacteria accidentally gave Earth oxygen, humans seem to be deliberately rewriting the chemistry in reverse. You wonder if some future creature will look back at these farms the way you look at the Great Oxidation Event, both as catastrophe and as turning point. You pause over a coal plant, watching steam rise into the sky, mixing with gases you can't see but know are there. For decades, humans debated whether these emissions could really change something as vast as the climate. Now the evidence is undeniable. Rising seas, fiercer storms, longer droughts. Historians still argue whether future generations will see this moment as one of ignorance or willful negligence. Did we really not know, or did we just not want to act? The argument matters less to the atmosphere than it does to human conscience. Still, the human story isn't only one of harm. You catch sight of solar panels glittering in the desert, wind turbines spinning lazily on a ridge. Renewable energy is humanity's attempt to rewrite its own script. It's clumsy, uneven, sometimes undermined by politics and profit, but it shows a flicker of awareness, the realization that the Earth is not a limitless sink for waste and fire. A quirky example, some engineers have proposed covering deserts with reflective panels to cool the planet, only to realize that doing so might alter rainfall patterns and create new problems. Solutions, it seems, can be as risky as the problems they try to fix. You drift higher again, looking down at the glowing networks of human civilization. It strikes you how quickly this footprint appeared. Just 10,000 years ago, humans were scattered bands of foragers, living lightly on the land. In evolutionary terms, that's a blink. In geological terms, it's not even a blink. It's a single eyelash falling. And yet in that instant, we've cut forests, dammed rivers, mined mountains, and filled the sky with gases. Earth's crust bears scars not from asteroids or volcanoes, but from bulldozers and drilling rigs. There's something almost comical about it too. Humans managed to invent tools sophisticated enough to land on the moon, yet also designed disposable forks durable enough to outlast monuments. Future geologists might puzzle over why a species so obsessed with convenience was also so reckless with permanence. Imagine a Martian archaeologist holding up a crushed soda can and whispering reverently, this was their crown jewel. But under the humour is unease. If extinction has always been part of Earth's story, humans are now accelerating it. Species vanish daily, habitats shrink, oceans acidify. And unlike past catastrophes, this one doesn't come from an asteroid or supervolcano. It comes from choices. Choices made by creatures smart enough to understand consequences, but often too short-sighted to change course. You hover above the glowing Earth, and the lights of cities suddenly look less like stars and more like sparks from a fire running out of control. And yet, here's the paradox. You feel a kind of bittersweet awe. This is what it looks like when a species becomes planetary in scale. No trilobite ever did this. No ammonite ever reshaped climate. Humans are both creators and destroyers, both miracle workers and calamities. The footprint is undeniable, and the question lingers. Will it shrink in time, or will it mark the beginning of the next great extinction? For now, the city lights still twinkle. The night still hums, and you drift onward, caught in the glow of a species that may outsmart itself or may yet surprise the world with resilience. The hum of cities fades as you glide toward the coasts, where land dissolves into water under the moonlight. At first it looks timeless, waves brushing the shore, gulls circling above, the faint salt tang in the air, but lean in closer and you'll notice something different. Whole stretches of coastline are changing shape. Where once there were dry streets, water now laps at the edges of buildings. Signs of humanity, faded stoplights, broken boardwalks, drowned piers stick out from the sea like abandoned relics. The line between land and ocean, once firm in your mind, has become blurred, restless, and shifting. You wander through a half-flooded neighbourhood. Windows glint just above the waves. Doors open into waterlogged rooms. Fish flicker past living rooms where families once gathered. There's something eerie about the quiet, as if time itself gave up here. Sea levels have risen more than 8 inches since the start of the 20th century, a number that sounds small until you multiply it across every coastline in the world. A few inches mean entire marshes swallowed, storm surges reaching farther, salt water intruding into drinking supplies. Historians still argue whether ancient societies like those on the Gulf Coast of Mesopotamia collapsed partly due to rising seas or shifting rivers. If so, today's drowned towns are just a modern replay of an ancient pattern. As you wade further, you pass by a statue tilted at an angle, its base eroded by salt. It reminds you of Heracleion, the Atlantis of Egypt, an entire port city that slid beneath the Mediterranean more than 1,000 years ago. Divers today swim through its ruins, past toppled temples and sunken trade goods, evidence that the ocean is always hungry. A quirky detail: when archaeologists discovered Heracleion in 2000, they found not only colossal statues but also tiny everyday objects, jewellery, dice, tools, still lying in the silt. It turns out when the sea claims land, it preserves memories along with it. But the flooding you see now is different. It isn't a single city lost to an earthquake or sudden collapse. It's gradual, global, relentless. You picture Miami streets turned into canals, Pacific islands shrinking year by year, entire nations like Tuvalu debating where their people might go when home is gone. Rising seas aren't dramatic like asteroid strikes, they're quieter, slower, like a tide that never stops coming in. And somehow that slowness makes it more haunting. You can watch it happen, inch by inch, yet feel powerless to stop it. You drift to the Arctic, where the water's surface is littered with icebergs breaking away from glaciers. Each chunk is like a page torn from a history book, floating into the sea. When glaciers melt, the land rebounds upward, as if the Earth is sighing in relief from the weight. Historians still debate how much sea level rise ended the last ice age, but they agree it reshaped coastlines dramatically, turning dry plains into today's North Sea and separating Britain from mainland Europe. Back then, humans simply moved inland. Today, billions live near coasts. Retreat isn't so easy when skyscrapers, ports, and megacities sit in the path of the water. You walk along a new shoreline, the air heavy with salt spray. Mangroves stretch out like fingers, trying to anchor the land. Some places adapt, wetlands migrate, deltas shift, but other places drown. You pause beside a church steeple sticking out of the waves, the only visible part of a once thriving village. Bells no longer ring, but the sea hums its endless refrain. Quirky as it sounds, divers sometimes train in these flooded towns, swimming through doorways, practicing rescue drills where neighbours once lived. Life adapts in odd ways, even to drowning. And yet, for all its menace, the ocean also feels indifferent. It isn't angry, it isn't targeting cities, it's simply following the physics of heat and expansion. Warmer water takes up more space, melting ice adds to the volume. The sea doesn't care if your favourite cafe is now an underwater reef, it only cares about balance. That indifference is unsettling. It means there's no villain to blame, no negotiation possible. The tide rises and you either move, adapt, or vanish. Hovering above a submerged street, you reflect on the irony. Humans built cities to feel permanent, stone, steel, concrete, monuments meant to outlast generations. Yet water, patient and soft, undoes them grain by grain. In some future epoch, geologists might discover skyscraper fragments beneath layers of silt and wonder about the people who lived there. They'll see not just human ambition, but also the ocean's signature, the slow reclaiming of space it never fully gave away. You linger on the edge of a drowned playground, swings creaking slightly as waves lap their rusted chains. For a moment, you imagine children still laughing here, playing above the tide, but the water doesn't stop. It rises, it spreads, it reshapes the map of the world, and the question lingers in the salt-filled air. Will you move with it, or will you join the ruins beneath it? For now, the sea only whispers at your feet, but its patience stretches longer than your species' memory. Tonight, you lie still, listening to the hush of waves, knowing they may one day climb higher than your own rooftops. You leave behind the drowned coasts and sail north, where the air sharpens with cold and the horizon gleams white. At first, it looks timeless. Vast sheets of ice stretching endlessly, glittering under pale sunlight. The kind of landscape you'd expect to be eternal. But take another step and you realize the ice is groaning, cracking, breaking away into the sea. The poles, the planet's frozen crowns, are melting, and with them vanishes not just scenery but memory, climate, and stability itself. You kneel to touch the edge of a glacier. It feels solid beneath your hand, ancient, almost alive. Some of these glaciers have been here since before human civilization began, storing within their layers tiny bubbles of ancient air. Scientists drill cores from them, pulling out cylinders of ice that trap snapshots of Earth's past atmosphere. By reading these frozen time capsules, we know what the air was like tens of thousands of years ago. It's like holding the breath of a Neanderthal in your hands. A strange, humbling thought. You're inhaling air shaped by the same cycles that those long-vanished ancestors once knew. But now, the ice is disappearing faster than at any point in recorded history. Arctic sea ice shrinks every summer, and while it returns each winter, the long-term trend is downward. Greenland's massive ice sheet sheds hundreds of billions of tons of ice every year. Antarctica, once thought too stable to lose mass quickly, is now bleeding ice as well. Historians still argue whether the West Antarctic ice sheet might collapse suddenly in the coming centuries or whether it will dwindle more gradually, but either outcome means higher seas and reshaped coastlines. The debate is not whether, it is how fast. You stand at the edge of a meltwater lake forming on top of the ice. The water is a brilliant turquoise, glowing against the white landscape. Quirky fact, these meltwater lakes sometimes drain suddenly, plunging through cracks to the bedrock below. Like hidden trapdoors, in hours they can carry more water than Niagara Falls. Imagine being a polar bear just trying to nap nearby, only to have your world swallowed in a giant glacial sinkhole. The poles are full of surprises, not all of them pleasant. Walking further, you notice the animals who depend on this frozen stage. A polar bear paces the thinning ice searching for seals. Walruses crowd beaches because the ice floes they once rested on have vanished. Penguins farther south march across shrinking platforms. You want to reassure them, but you can't. Their habitat isn't just shrinking, it's unravelling. The ice is the foundation of entire ecosystems, and when it goes, the web above it trembles. The melting poles don't just change the scenery, they alter the planet's balance. The Arctic reflects sunlight back into space, acting like a mirror. As the ice retreats, darker ocean water absorbs heat instead, accelerating warming, a feedback loop. Scientists call this the albedo effect, but you can think of it as Earth changing its wardrobe from white linen to black leather. It might look stylish, but it heats things up quickly. Historians still debate how such feedbacks shaped past warm periods, like the one 125,000 years ago, when sea levels were several meters higher than today. The past whispers warnings, but the details remain fuzzy. You lean down and scoop up a chunk of ice, hold it to your ear as if it might speak, and in a way it does, popping and cracking as tiny air bubbles escape, ancient whispers released after thousands of years. Each sound is a reminder that once this ice is gone, it doesn't come back quickly. It took millennia to build, centuries to store, but only decades to melt. A one-way ticket for glaciers, with no return trips available. A curious tidbit comes to mind. During the Cold War, both the US and Soviet Union considered building secret bases inside the ice sheets. Project Iceworm, for example, was an American plan to hide nuclear missiles under Greenland's ice. It didn't work, the ice was too unstable even then. Yet the idea lingers as a strange testament to human hubris, imagining the poles as permanent fortresses when in fact they were always shifting, restless, temporary. You climb a ridge and look out over the endless white, knowing much of it will be blue water within your lifetime. Entire shipping routes are opening through the Arctic now, once impossible because of year-round ice. To some, it looks like opportunity. To others, it looks like a warning. You can almost hear the ice groan at the irony, melt caused by industrial activity making new paths for more industrial activity. And yet, standing here, the silence is stunning. The poles hum with a quiet so profound it feels sacred. The crunch under your boots, the faint whistle of wind, the distant crack of icebergs carving into the sea, that's all. You realise that even as the ice vanishes, it carries a message. Fragility can look enormous, permanence can dissolve, and what seems eternal can disappear within a blink of geological time. You close your eyes and let the cold air sting your cheeks. Somewhere, far away, the world is warming, seas are rising and species are struggling. But here, for this moment, the ice still holds, the horizon still gleams, and the frozen memory of the earth is still intact, whispering its story before it melts away. You leave the polar silence behind, but the sound doesn't vanish. It transforms. The hush of snow and cracking ice turns into the roar of storms, the crackle of wildfires, the dry rasp of desert wind. You find yourself wandering through a landscape of climate feedbacks, those self-reinforcing loops that take a nudge and spin it into a shove. At first glance, Earth's climate seems like a thermostat, adjusting smoothly, keeping things comfortable. But walk a little further, and you see that thermostat can stick, jam, or swing wildly, sometimes pushing the system into entirely new states. The air grows hotter as you move into a desert, sand dunes stretching across the horizon. Grains sting your skin as wind carves new shapes, whispering endlessly across the barren plain. Deserts spread when rainfall patterns shift, often triggered by warming oceans or deforestation. The Sahara, which you picture as eternally dry, was once green, filled with lakes and animals. Historians still argue why it dried out around 5,000 years ago, whether shifts in Earth's orbit or human overgrazing tipped the balance. But the outcome is clear. A lush cradle of life became a dust-filled expanse. Now, as global temperatures rise, deserts edge outward again, swallowing farmland and villages one storm at a time. From sand, you step suddenly into fire. A forest burns around you, the air thick with smoke, branches collapsing in showers of sparks. Wildfires are natural, part of renewal in some ecosystems, but as heat intensifies and droughts lengthen, fires grow fiercer, more frequent, harder to stop. You remember that in 2020, fires raged so fiercely in Australia that the smoke circled the entire globe. Quirky fact, some seeds, like those of certain pines, actually need fire to open and sprout, but even nature has limits. Too much fire too often, and forests don't recover. They turn into grasslands or deserts, shifting the balance of carbon storage and heating the planet even further. And then, as the smoke clears, you step into a storm. The ocean heaves beneath dark skies and hurricanes roar to life. Warmer seas feed them, pumping more energy into each swirling spiral. You hover over towering waves, watching entire coastlines brace against winds that tear roofs away like paper. In 2005, Hurricane Katrina drowned New Orleans. In 2013, Typhoon Haiyan flattened parts of the Philippines. Historians still debate whether specific storms can be directly blamed on climate change, but they agree on the trend. Warmer oceans mean stronger storms. When heat rises, chaos follows. You realise the loops are all connected. Melt ice at the poles, and less sunlight is reflected, warming oceans. Warm oceans and storms intensify, eroding coasts. Burn forests, and carbon floods the air, trapping more heat. It's like Earth's systems are dominoes, each toppling the next. The feedbacks amplify each other, turning manageable problems into runaway cycles. You step back and look at the pattern. Deserts, fires, storms, all signs that the climate is not just changing, but changing faster than societies are built to handle. A quirky story floats to mind. In the Middle Ages, Europe experienced what's now called the medieval warm period, followed by the Little Ice Age. Crops shifted, wine grapes grew further north, rivers froze solid. People threw frost fairs on the frozen Thames, skating, drinking and dancing on ice thick enough to support tents. Historians still argue whether these changes were mostly solar-driven or volcanic, but the lesson stands: even small shifts in climate ripple through human life, toppling kings and rewriting economies. If those relatively minor swings had such power, imagine what today's rapid warming will do. You wander into the Amazon, lush and green for now, but carrying a tension in the air. If deforestation continues and rainfall patterns shift, this rainforest could cross a tipping point. Instead of storing carbon, it might release it, turning from a sink into a source. Imagine the world's lungs suddenly exhaling everything at once. The debate isn't whether ecosystems have tipping points, but when they'll be crossed, and whether we'll even notice until it's too late. It's unsettling, but there's humour in the absurdity too. Humanity argues endlessly about thermostats in office buildings, bickering over a degree or two, while Earth's thermostat swings wildly between ice ages and heat waves. You picture cavemen sitting around a fire grumbling, "It's too hot," while glaciers loomed just over the horizon. Some things apparently never change. You pause on a ridge overlooking the shifting landscapes, sandstorms on one side, hurricanes on the other, fire glowing in the distance, ice cracking at the horizon. It looks chaotic, but it isn't random. It's a pattern of feedbacks, loops upon loops, all tied to the physics of heat and water. The Earth you rely on for stability is more like a tightrope walker, wobbling, occasionally slipping, sometimes catching balance, sometimes crashing hard. And yet, even in this precarious dance, life persists. Grass sprouts through charred soil. Desert plants store water in cunning ways. Birds ride the storm winds and find shelter when the sky's clear. The loops can spiral, yes, but resilience is also part of the system. Earth may become harsher, less familiar, more hostile, but it rarely becomes completely still. That thought doesn't erase the danger, but it adds a strange kind of comfort. As the storm winds die down and the fire fades, you sit quietly on a dune, watching the clouds shift overhead. You know feedbacks can push Earth toward inhospitability, but tonight, under this momentary calm, you still breathe easily. The loops haven't closed yet, the balance hasn't tipped fully. You have time, whether you use it wisely is another story. The winds settle and the clouds thin, but you feel a new kind of unease, not the rumble of Earth's core or the whisper of melting ice this time, but a vast silence when you lift your gaze beyond the sky. Out there, past the atmosphere, space looks calm, velvet black with pinprick stars. But you know better. That darkness is littered with hazards, some tiny, some cosmic in scale. All of them reminders that Earth is not only threatened from within, but also from above. You tilt your head back, and the thought is almost absurd. This fragile planet is dodging bullets every day. Take asteroids, for example. Most of the time, they're harmless rocks orbiting quietly in the belt between Mars and Jupiter. But sometimes, gravitational nudges send them Earth's way. You think of the Chicxulub impactor, the 6-mile-wide space rock that ended the reign of non-avian dinosaurs 66 million years ago. It hit with a force billions of times more powerful than nuclear bombs, triggering tsunamis, wildfires, and a global winter that lasted years. Without it, you probably wouldn't be here. Yet the unsettling part is knowing there are still countless rocks out there, each one a potential reset button. Historians still argue whether smaller impacts in earlier times shaped evolutionary leaps, or whether they were mere bumps in the road, but the craters scattered across continents are undeniable evidence that Earth is no stranger to cosmic collisions. You float closer to one such scar, the Barringer crater in Arizona. Just over a kilometre across, it was created by a rock only 50 metres wide. A quirky fact: when it was discovered in the early 1900s, many geologists thought it was volcanic. The idea of asteroid impacts seemed too far-fetched at the time. It wasn't until decades later that scientists confirmed it was indeed an impact site, proof that even relatively small rocks can leave massive, lasting marks. 50 metres is barely the size of a swimming pool, yet it reshaped a desert. Sobering thought for your midnight walk. Comets add another layer of drama. Unlike asteroids, they're icy wanderers from the far edges of the solar system. When they streak close to the sun, their tails glow across the sky, beautiful and ominous. Some ancient cultures saw them as omens of disaster. The Bayeux Tapestry even depicts Halley's Comet above the 1066 Battle of Hastings, a fiery streak witnessed by both armies. Historians still debate whether such appearances genuinely swayed decisions or were interpreted only in hindsight, but the symbolism remains powerful. Comets were cosmic warning signs. And then there are gamma-ray bursts, the universe's cruelest fireworks. Imagine a distant star collapsing or colliding, releasing a beam of radiation so intense it could sterilize life across entire planets if Earth happened to be in its line of fire. Luckily, most of them point elsewhere. But the mere possibility is a reminder that the cosmos isn't just pretty, it's predatory in ways you can't control. Some scientists speculate that ancient mass extinctions may even have been triggered by such radiation events, though the evidence is thin and debated. Still, the idea that life could vanish in seconds because of a flash from across the galaxy is enough to make you clutch your blanket tighter. A quirky tidbit softens the tension. In 1972, an asteroid called 1972 Apollo zipped past Earth, so close it entered the atmosphere, skipped across like a stone on water, and went back into space. If its angle had been slightly different, it would have detonated with the force of a nuclear bomb over Canada. Instead, it gave us a celestial game of billiards and a nervous chuckle in hindsight. Space hazards sometimes play out like cosmic slapstick. Funny until they're not. You drift higher still, past satellites and space junk orbiting the planet. Humanity has added its own layer of risk. Thousands of defunct machines circling Earth like a scrapyard in slow motion. A single collision can shatter satellites into shrapnel, creating a chain reaction called the Kessler syndrome. Imagine trying to launch anything into orbit through a hailstorm of your own trash. The irony is sharp. Humans are not only threatened by natural space rocks, but by the junk we've left up here ourselves. Looking back at Earth, glowing blue against the dark, you realise how vulnerable it looks. No armour, no shields, just atmosphere and hope. It's as though the planet is standing at the centre of a cosmic shooting gallery, dodging bullets on luck and physics. The fact that life has survived this long feels miraculous. And yet, you know the dice will keep rolling. The question isn't whether Earth will be hit again, it's when. Still, you exhale and let the thought soften. These threats are real, yes, but they're also rare on human timescales. The sky has always held dangers, but it has also given you light, beauty, navigation, and wonder. Every shooting star you've wished upon is technically debris burning up, harmless this time. Most nights the universe offers awe instead of annihilation. And in that delicate balance you find something strangely reassuring. Survival, at least for now. You lower your gaze back to the horizon. Earth spins steadily beneath you, fragile yet enduring, improbable yet stubborn. For tonight, the rocks miss, the comets pass by, the gamma rays aim elsewhere. You're safe under the stars even if the safety's borrowed. The stars remain overhead. But you let your focus slide back to the sun, your familiar fiery anchor in this spinning dance. Until now, you've thought of it as a steady provider, a golden metronome keeping time across billions of mornings, but when you stretch the timeline out far enough, the sun becomes less a gentle companion and more a ticking clock. Its steady burn isn't truly steady. It's a long, slow transformation, one that will eventually make Earth uninhabitable no matter what else happens. You float closer to that glowing orb, feeling both warmth and unease. The sun is middle-aged right now, about 4.6 billion years old, with roughly another 5 billion years of fuel left. In human terms, it's like a 40-something jogger who still looks fit but has already scheduled their first knee surgery. The fusion of hydrogen into helium keeps the sun shining. But as the hydrogen diminishes in the core, the balance shifts. Gravity squeezes, pressure rises, and the star burns hotter, brighter. Scientists estimate that in just 1 billion years, the sun's increased output will make Earth too hot for liquid water. Oceans will shrink, clouds will vanish, and the once hospitable surface will turn arid. You might think 1 billion years is plenty of time, but on cosmic scales, it's a fast-approaching deadline. You picture Earth under that harsher star, deserts stretching across continents, coastlines gone, plant life gasping in the heat. Historians still argue whether photosynthetic life could hang on in shaded niches for a while or whether the collapse would be sudden, but either way the stage is set. Habitability has an expiration date baked right into the solar system. And then comes the red giant phase. In about 5 billion years, the sun will exhaust its hydrogen entirely. Its core will contract and heat, while its outer layers balloon outward, swelling to hundreds of times its current size. Mercury and Venus will be engulfed, and Earth stands a very good chance of following them into the furnace. If by some miracle it isn't swallowed, it will still be scorched into a molten husk. The oceans will have long since boiled away. The atmosphere will be stripped. Whatever remains of your planet will be unrecognizable, more like Mercury than the blue marble you love. You hover at the imagined edge of that swollen red sun, its atmosphere billowing outward like fiery cotton. It's beautiful and terrifying all at once. Quirky fact, when the sun reaches this phase, it might pulse in brightness, shrinking and expanding over thousands of years, like a slow-motion heartbeat across space. To an observer on a distant world, it will look like a star shuddering its last breaths. For Earth, those pulses will be tidal waves of heat and radiation. The calm, predictable sun you know will die dramatically, flamboyantly, leaving behind no doubt about its power. Eventually the red giant will shed its outer layers entirely, creating a planetary nebula, a glowing bubble of gas expanding into the void. At its centre will remain only a white dwarf, the dense ember of the star that once warmed your world. It will glow faintly, cooling slowly over trillions of years. Earth, if it survives physically, will orbit this ghost sun silently, barren and cold. Historians still debate whether planets like Earth will remain in orbit around white dwarfs or be flung into space by the chaos of stellar death, but in either case, habitability is gone. What was once paradise will be rubble, circling or drifting in silence. You pause to take this in. The sun's fate is not cruel or malicious, it's just physics. Stars are born, they burn, they age, they die. Your existence is timed perfectly in the middle of this process, like slipping into a concert for the sweetest notes before the finale gets loud and messy. The very fact that you exist during this calm Middle Age is remarkable. Billions of years ago, the sun was too unstable. Billions of years from now, it will be too violent. Right now, it's just right. You're living in the cosmic intermission. There's a kind of poetry in knowing the sun will one day paint the sky with its final gasps, a nebula glowing across space. Quirky thought, perhaps some distant civilization far away will look at that glowing bubble and marvel at its beauty, not realizing it once hosted a small blue planet full of noisy humans arguing over Wi-Fi speeds and pizza toppings. To them, it will simply be art, a cosmic flower blooming in the dark. You sit quietly, imagining the far future Earth, silent, baked, stripped. And instead of fear, you feel an odd release. This was always the deal. No world lasts forever. No star burns eternally. You're borrowing time, and the loan terms were always clear. Enjoy it while it lasts. Tonight, the sun still rises, still sets, still gives warmth through your window. That is enough. You drift away from the vision of a swelling red sun and find yourself stepping onto a nightmare Earth, one that feels strangely familiar, yet completely alien. The air is heavy, dense, and hot, like stepping into a sauna that no one remembered to turn off for a few million years. The ground beneath you is cracked, scorched, with shallow pools of boiling water hissing at the surface. Above, thick yellow clouds roll across the sky, trapping heat like a suffocating blanket. This is Earth transformed by a runaway greenhouse effect, a version of the planet that looks less like home and more like Venus, your toxic neighbour. The runaway greenhouse is simple in theory but devastating in practice. Greenhouse gases, carbon dioxide, methane, water vapour, trap heat in the atmosphere. A little of this is necessary. Without it, Earth would be a frozen wasteland. But too much, and the cycle accelerates. Heat evaporates oceans, water vapour thickens the atmosphere, trapping more heat, evaporating more water, and so on, until the planet crosses a point of no return. You take a breath, or try to, and realise the air is hot enough to scald your lungs. Even if oxygen were still present, the pressure and temperature would crush you. Scientists study Venus as a warning. That planet may once have had oceans, but now its surface simmers at nearly 900 degrees Fahrenheit, hot enough to melt lead. Its clouds are made of sulfuric acid, and its surface pressure is 90 times that of Earth's. Historians still argue whether Venus always lacked oceans, or whether it truly lost them to a runaway greenhouse billions of years ago. Either way, the comparison is chilling. You can't help but wonder, could Earth stumble down the same path? You wander through this vision, your footsteps sticking to blackened ground. Oceans that once roared with life are now gone, boiled into thick vapour that smothers the sky. Mountains rise like skeletal remains above plains of cracked clay. The irony is brutal. Water, once Earth's gift, has become its executioner. A quirky fact comes to mind. Water vapour is actually the most powerful greenhouse gas in Earth's atmosphere today, but it's usually balanced by temperatures and circulation. In this runaway state, though, it dominates completely, sealing the planet's fate. And here's the haunting part. the tipping point might not be as distant as you'd like to think. While Earth isn't expected to naturally reach full Venus mode for at least 1 billion years, unchecked human emissions could push climate closer towards smaller-scale versions of the same runaway dynamics. Historians still debate whether the Permian extinction, the Great Dying, was fueled by runaway greenhouse feedbacks from methane and carbon dioxide. The record suggests Earth has teetered near the edge before. It doesn't take imagination to picture it happening again. You pause to touch a rock that crumbles under your hand, baked brittle by relentless heat. Imagine walking through cities in this world, steel warped, concrete fractured, glass melted into rivers. Civilization's fingerprints erased, not by war or asteroid, but by the sky itself refusing to let go of its heat. Future geologists, if any existed, wouldn't find ruins so much as strange, melted signatures in stone. The Eiffel Tower would be slag. The pyramids would be dunes, humanity's proud monuments erased by a planetary fever. Quirky detail. On Venus, spacecraft sent to the surface don't last long. The Soviet Venera probes in the 1970s managed to transmit data for only about an hour before the heat fried their electronics. Imagine spending years building a spacecraft, only for it to melt like a marshmallow over a campfire. That's how hostile a runaway greenhouse planet can be. And yet here you are, standing in a speculative version of Earth that feels eerily close. The oppressive air makes you imagine sounds, perhaps a hiss as oceans boil, the faint crackle of minerals breaking under heat, the thunder of storms in a sky that no longer rains but only rages. You realise no birds sing here, no insects buzz. The planet is not silent, but it is lifeless. A stage without actors, a play without dialogue. You step back, trying to view this Earth from orbit. It looks pale, cloud-choked, swollen with vapour. From space, it would seem eerily beautiful, glowing white and gold, shrouded in mystery. Distant astronomers might marvel at it, not knowing it once held forests, cities, and oceans. To them, it would simply be another Venus, a world inhospitable to life. That thought chills you more than the imagined heat. Earth's habitability, its uniqueness, could be erased so completely that no one would ever guess what was lost. And yet, in the stillness of this nightmare vision, you feel something familiar. Warning, yes, but also perspective. This is not Earth today. Oceans still crash against shores, forests still breathe, clouds still bring rain. You are standing in a fragile balance, yes, but not yet in the runaway spiral. That gap is both terrifying and hopeful. It means there is room to change, room to adapt, room to avoid slipping into Venus's shadow. You breathe deeply, imagining cool night air filling your lungs instead of this suffocating heat. You remind yourself, tonight, Earth is still habitable, still generous, still miraculous. But the vision lingers, a reminder of what could happen if balance tips too far. The suffocating heat of the Venus-like nightmare fades, and suddenly you feel something invisible brushing against your skin, subtle but unsettling. It's not wind, not warmth, it's radiation, streaming in from the cosmos. Normally you never notice it, because Earth shields you with its magnetic field, an invisible force field generated deep within the churning iron core. But tonight, you're stepping into a version of the planet where that shield weakens, where cosmic rays and solar storms push closer, where the protection you've always taken for granted flickers like a dying candle. The magnetic field is born in Earth's molten outer core where liquid iron swirls in constant motion. This movement acts like a dynamo, generating a vast magnetic bubble called the magnetosphere. It deflects charged particles from the sun, keeping the atmosphere intact and radiation at bay. Without it, the surface of Earth would be as barren as Mars, stripped of air and water. You may not see it, but every compass needle, every aurora, every safe breath you take is tied to this restless iron heart beneath your feet. But the field isn't as permanent as you'd hope. It drifts, it wobbles, it weakens, and every so often, it flips entirely. Magnetic north becomes south, and south becomes north. Historians still argue over how quickly these reversals happen. Some evidence suggests they can take thousands of years, others hint at sudden jumps. What's certain is that during these transitions, the field weakens. leaving the planet more exposed to solar radiation. For humans, it might mean higher cancer risks, disrupted satellites, and power grids frying during solar storms. For the atmosphere itself, it could mean slow erosion, gases drifting away into space. You picture the sun hurling a storm of charged particles toward Earth, like it has countless times before. Normally, the magnetosphere bends those streams around the planet, lighting up the poles with auroras. But in this weakened state, more particles crash through, frying electronics, jamming communications. Imagine waking up to no internet, no satellites, no power, modern civilization blinking off, not from war or greed, but from the sun flexing its muscles while Earth's shield wavers. A quirky fact comes to mind. The last full reversal of Earth's magnetic field happened about 780,000 years ago. Known as the Brunhes-Matuyama reversal, it left clear marks in volcanic rocks that recorded the flip. But here's the odd part. There's no evidence of mass extinctions linked to it. Life survived, adapted, shrugged off the change. Still, some scientists warn that the modern world is uniquely vulnerable. Cavemen didn't rely on GPS satellites or power grids. You do. You walk across a plain where compasses spin uselessly, pointing nowhere. Birds overhead struggle to navigate, their internal magnetic senses scrambled. Turtles that once followed magnetic cues to nest wander aimlessly. Some animals might adapt, others might falter, but the disruption ripples through ecosystems. Historians still debate how much wildlife depends on magnetism and how resilient those species would be if the field collapsed. The uncertainty itself is unsettling, another reminder of how much you depend on forces you can't see. You kneel beside an aurora, blazing not just at the poles but across the entire sky. Red and green curtains unfurling overhead. It's beautiful, surreal, like the heavens themselves have caught fire. But this beauty is also danger, a visible sign of solar storms reaching further than they should. You can't help but laugh at the irony. Humanity would probably post millions of breathtaking photos of global auroras on social media, right before those same storms knocked the internet offline. A once-in-a-lifetime view, followed by a once-in-a-civilization blackout. Another quirky tidbit. During a magnetic storm in 1989, currents induced in power lines knocked out electricity across Quebec for 9 hours. Millions sat in the dark, all because of an event 93 million miles away. And that was with the magnetosphere intact. Imagine a similar storm with Earth's shield weakened. The scale of disruption could stretch far beyond a regional blackout, potentially global. You drift outward, looking at Earth from space. The shimmering bubble of the magnetosphere is still there, but thinner, patchier, like fabric fraying at the edges. Charged particles pierce through, some reaching the upper atmosphere where they trigger chemical reactions that eat away at ozone. It's a subtle erosion, not as dramatic as an asteroid strike or runaway greenhouse, but just as insidious. Over millennia, the air itself could bleed away. Mars, after all, once had flowing rivers, seas, and maybe even life. Today it's a dry husk, in part because it lost its magnetic shield. Back on the surface, you imagine living under a sky where radiation levels are high enough to make outdoor life dangerous. People might shelter underground or in domed cities, shielding themselves with layers of rock or metal. The planet itself would remain, but its surface would become hostile, forcing life to burrow or vanish. Not sudden annihilation, but a long, slow narrowing of possibilities. And yet you remind yourself, Earth's magnetic field has survived for billions of years. It's flipped, wobbled, weakened, but always returned. The core still churns, the dynamo still hums, the shield still holds, for now. The very fact that you can stand here breathing, scrolling on your phone, or falling asleep to these words is proof that the invisible armour is doing its job. Fragile, yes. Temporary, yes. But still here. You sit on a rock, watching the auroras ripple unnaturally bright across the horizon. They're warnings, but they're also wonders. Maybe that's Earth's way of reminding you. Even its vulnerabilities can be beautiful. The shield may not last forever, but tonight, it still cradles you, a silent guardian humming beneath your feet. You rise from the glowing sky curtains and look down again, but instead of the familiar shapes of today's continents, you see something else. Land masses fused into sprawling, barren megacontinents. The outlines of Africa, the Americas, Asia and Europe blur and merge into one giant expanse of stone, fringed by vast empty oceans. The sight is unsettling, like staring at a puzzle that's been forced together in the wrong way. And then you remember, continents don't stand still. They drift, collide, tear apart. Given enough time, Earth reshuffles its map completely, and the future it's planning doesn't look particularly welcoming. The mechanism is slow but relentless. Plate tectonics, the movement of Earth's crust over its molten underbelly. Right now, the Atlantic Ocean is widening as North and South America drift west, while the Pacific shrinks. Millions of years from now, these shifts will force continents back together into what geologists call a supercontinent. It's happened before, Pangaea, around 335 million years ago, when nearly all land was fused into a single giant mass. Before that, there was Rodinia, even older. Supercontinents form, break apart, reform, like Earth's version of breathing. Historians still argue how regularly this supercontinent cycle repeats, but the evidence suggests it's inevitable. You walk across this imagined future supercontinent, sometimes called Pangaea Ultima or Amasia, depending on the model. The land stretches endlessly, flat in places, mountainous in others, but overwhelmingly dry. Why? Because supercontinents come with brutal climate extremes. The interior is far from the moderating influence of oceans, so summers scorch and winters freeze. Rain struggles to reach the centre, leaving deserts sprawling across the middle. You imagine standing there, no forests, no rivers, just an arid emptiness under a blazing sky. A quirky fact, the centre of ancient Pangaea may have been so dry that sand dunes taller than skyscrapers rolled across what's now the eastern United States. Fossilised dunes still stand today in places like Zion National Park, silent evidence of a time when North America looked more like the Sahara. Walk among them now, and you're literally hiking through the bones of an ancient desert. Back in your future vision, the coastlines aren't much kinder. The vast new ocean, sometimes called the Panthalassa of tomorrow, heaves with storms. With so much water concentrated in one place, hurricanes might grow titanic, slamming the supercontinent's edges with relentless fury. Meanwhile, volcanic belts form where the crust collides, belching gases, shaking mountains into existence, and further destabilizing climate. Historians still debate whether these tectonic mega-events have triggered past mass extinctions. Some point to the Siberian Traps eruptions at the end of the Permian, which coincided with the Great Dying. Others caution the connections are messy. Still, the timing feels suspicious. You kneel to study the ground. The soil is thin, cracked. Without abundant rainfall, farming would be nearly impossible in the continental interior, even if humans, or whatever species evolves next, managed to survive into this distant era. Feeding large populations would be daunting. Technology might provide workarounds, greenhouses, desalination, underground farms, but the environment itself would be hostile. This isn't a planet that welcomes complexity. It favours resilience, toughness, maybe even regression to simpler life forms that can endure harsh swings in temperature. You wander toward a volcanic rift splitting the supercontinent. Lava spills slowly, red rivers glowing under the stars. Here lies the other danger, carbon dioxide. As continents smash together, mountain ranges rise, but as they split apart again, volcanoes belch gases into the sky. The carbon cycles accelerate, adding another layer of climate chaos. Earth has always balanced between icehouse and greenhouse states, but with a supercontinent, those swings can be exaggerated, whipping the planet between extremes like a roller coaster with no brakes. Quirky thought, the word Pangaea comes from Greek, meaning all Earth. When Alfred Wegener proposed the idea of continental drift in the early 20th century, most scientists laughed him off. They couldn't believe continents could move. It took decades, and the discovery of seafloor spreading, for his theory to be accepted. Today, it's common knowledge. Tomorrow, it's prophecy. You climb a ridge and look out over this future Earth. There are no familiar coastlines, no recognizable maps. It feels alien, but it's still Earth, still turning under the same sun. And yet, you sense that such a configuration will strain life. Species that depend on mild climates may vanish. The interiors of continents may become wastelands. survival here won't be about flourishing, but about enduring. Historians still argue whether supercontinents mark low points in biodiversity, but the fossil record hints at tough times whenever the land fuses together. Sitting on the ridge, you imagine yourself as a wanderer millions of years from now, trekking across deserts that used to be oceans, climbing mountains that once lay beneath waves. The air is hot, dry, heavy with volcanic haze. Oceans thunder far away, unreachable. The idea of Earth as a habitable planet feels strained. Yes, life persists, but comfort has been stripped away. Habitability doesn't vanish overnight. It shrinks, it narrows, it becomes more conditional. And so you linger on this strange landscape, aware that even if asteroids miss, if the magnetic field holds, if humanity avoids its own follies, the planet's tectonic pulse will eventually deliver this new face. The continents that now cradle your cities and forests will fuse into something barren, something harsh. Earth will still be alive, but in a way that leaves you wondering whether it can still be called home. The vision of scorched supercontinents drifts away, and you find yourself back in the present, where humans, never quite satisfied with waiting for nature's catastrophes, are already sketching out blueprints for how to outwit the planet itself. The phrase that floats to mind is geoengineering, the audacious, sometimes desperate idea that if Earth systems are spiralling toward inhospitability, perhaps you can reach up and tweak the controls yourself. It sounds bold, like science fiction, but as you walk through the halls of proposed solutions, you realize it's also messy, controversial and risky, more like trying to fix a cracked vase with duct tape and hoping no one bumps into it again. One of the most talked about ideas is stratospheric aerosol injection. Picture fleets of planes spraying reflective particles high into the atmosphere, mimicking the cooling effect of volcanic eruptions. After Mount Pinatubo erupted in 1991, global temperatures dipped by about 0.5 degrees Celsius for a year. That single volcanic belch provided a natural experiment, suggesting that dimming the sun just slightly could buy humanity time. But walk through the haze of this proposal, and the problems loom. Dimming the sun doesn't just cool the planet evenly, it also risks disrupting rainfall patterns, monsoons and agriculture. Imagine fixing global warming but causing droughts where billions depend on rain. Historians still argue whether tinkering with planetary systems is salvation or hubris, but the very fact that the debate exists tells you how urgent the situation feels. Another scheme gleams in your imagination: giant mirrors in space, positioned to deflect sunlight before it even reaches Earth. The concept reads like a Bond villain's diary, but scientists have run the math. A sunshade the size of a continent could theoretically reduce solar input enough to cool the planet. The catch? The engineering is staggering, the cost astronomical, and the maintenance nightmarish. Quirky fact: one proposal suggested sending 1 trillion tiny disks into orbit at Lagrange points, where gravity balances perfectly, creating a shimmering parasol. It sounds more like cosmic confetti than a practical plan, but it reveals the lengths humans will imagine going to when faced with planetary fever. You wander into another wing of the geoengineering gallery, carbon removal. Here the strategy isn't to dim the sun, but to suck the problem out of the air. Machines that pull CO2 directly from the atmosphere and store it underground, algae farms designed to absorb carbon, crushed minerals sprinkled across landscapes to accelerate natural weathering. Each idea carries promise, but also scale problems. A few demonstration plants exist, whirring away like futuristic air purifiers, but to make a real dent, they'd need to operate by the millions. Imagine building a second industrial revolution just to clean up the mess of the first. A quirky tidbit here: in Iceland, one such plant called Orca already captures CO2 and injects it into volcanic rock, where it turns solid in a couple of years. It's like bottling the atmosphere and burying it. The process works, but the cost per ton of carbon removed is currently so high, it makes luxury handbags look like bargains. For now, it's proof of concept rather than salvation. And then there's the ocean. Some proposals suggest seeding iron dust into nutrient-poor waters, encouraging algae blooms that would absorb carbon and sink to the seafloor. On paper, it's elegant. In practice, it risks creating dead zones, altering ecosystems, and producing toxic side effects. Historians still argue whether smaller experiments already showed the dangers outweigh the benefits. The ocean, vast as it is, doesn't always appreciate being tinkered with. You pause in this hall of possibilities, feeling both impressed and uneasy. Humanity's genius lies in dreaming up solutions, but so often those solutions come with unintended consequences. Geoengineering feels less like building a stable bridge and more like juggling knives while walking across it. Yes, the knives are flashy, and yes, they might keep you moving forward, but one slip and the damage could be worse than before. Still, there's something deeply human about the audacity. You imagine prehistoric people staring at fire, wondering if they dared control it. You imagine farmers carving irrigation ditches, rerouting rivers to grow crops. In every era, humans have tried to engineer their environment to survive. Geoengineering is simply that instinct written large, applied not to a field or a village, but to the entire planet. You step outside and look up at the sky. Planes streak across it, and for a moment you picture them not as passenger jets, but as future aerosol spreaders, misting the stratosphere with reflective dust. It's both chilling and oddly mundane. Would people even notice, or would the altered sky simply become the new normal? Maybe. In some future documentary, children will hear the phrase, blue sky, and wonder why we ever thought of the colour as special. And yet, despite the risks, you can't shake the feeling that some form of geoengineering may eventually happen. Desperation breeds boldness, and as climate stresses mount, the temptation to pull levers, to dim the sun, to tweak the air, will grow. Whether it saves you or damns you, no one can yet say. What you do know is this: habitability has always been precarious, and humans, unlike trilobites or ammonites, at least have the imagination to try bending the odds. So you sit quietly, listening to the hum of the present world. The air is still breathable, the ocean still alive, the forest still green. Geoengineering remains mostly theory, scribbles on paper and small experiments in the field. But it hovers in the background like a safety net, or perhaps like a loaded gun, waiting for the moment someone decides to use it. The thought of aerosols and space mirrors drifts away, and now you find yourself walking into a different kind of future, one where Earth has already lost too much of its natural balance, and survival depends not on fixing the planet, but on sealing pieces of it away. You pass through the shadow of a dome, vast and gleaming, arching high overhead like the shell of a glass cathedral. Inside, the air is cooler, filtered, controlled. Outside, the sky swirls with dust, heat, and ultraviolet light. This is the era of domed cities, humanity's attempt to recreate Earth's gift in miniature after the larger system falters. You wander inside one of these bubbles. It feels strange, familiar, yet artificial. Trees line the walkways, leaves rustling softly in recycled breezes. Rivers flow, but you know the water is purified endlessly, a closed loop. The dome hums faintly with the energy of fans, pumps, and filters. Every element of the environment, once given freely by the planet, must now be engineered and maintained by human hands. Habitability is no longer a gift. It's a subscription service, renewable only as long as the machines keep running. The idea isn't new. In the 1990s, scientists built Biosphere 2 in Arizona, a giant sealed environment meant to test whether humans could survive in a closed system. It contained rainforests, deserts, and even a mini ocean. 8 people lived inside for 2 years, but the experiment ran into trouble. Oxygen levels fell, crops struggled, and tensions flared among the crew. Historians still debate whether Biosphere 2 was a noble failure or a misunderstood success, but its lesson was clear. Recreating Earth systems is harder than it looks. Even when you think you've accounted for everything, 1,000 tiny interactions slip past your calculations. Still, the allure of domes persists. You imagine megacities beneath translucent shells, shielding residents from radiation, storms, or toxic air. Some designs even propose vertical farms stacked like towers inside, glowing with artificial light, feeding millions without a single open field. Quirky fact, engineers in the Middle East have proposed building climate-controlled arcologies, massive domes or enclosed skyscraper cities designed to withstand desert heat. None have been built at scale yet, but the drawings look like something out of a science fiction novel. Glass hives glowing against a barren horizon. Inside the dome, people adapt. Seasons are simulated, rainfall is scheduled. Day and night become programmable, more theatre than reality. Children grow up without ever feeling real wind on their faces, only the steady circulation of fans. They might look at historical films of open landscapes, the way you look at old paintings of mythological beasts, half in wonder, half in disbelief. The Earth itself, once an endless playground, has shrunk to a handful of habitable bubbles scattered across its surface. You pause at the dome's edge and place your hand on the glass. Outside, the heat distorts the horizon. Dust whips across skeletal remains of forests. Rivers lie cracked and dry. Perhaps radiation storms flicker across the sky. Auroras too dangerous to admire. The divide is stark. Inside, life continues in careful balance. Outside, the planet continues its long slide toward unlivability. The dome feels safe, but also like a prison. You are protected, yes, but only by surrendering the wildness that once defined Earth. A quirky tidbit creeps into your mind. During the 20th century, architects like Buckminster Fuller designed geodesic domes and imagined covering entire cities like New York with them, shielding them from smog and weather. It was an era when optimism about technology was so high that sealing off Manhattan didn't sound absurd. Today, it reads as both visionary and desperate. What was once dismissed as fantasy could become necessity. Of course, domes are not invincible. They crack, they require constant energy, they depend on complex supply chains. A single failure in filtration, a single breakdown in power, and the bubble becomes a tomb. That vulnerability echoes through your thoughts as you listen to the steady hum of the systems around you. The fragility isn't just outside anymore, it's inside too, built into the very structures designed to protect. Historians still argue whether humans will ever truly choose domes on Earth, or whether they'll be reserved for colonies on Mars or the Moon. But the debate misses the point. The mere fact that the idea exists, that we sketch domes into our imagined futures, proves something profound. We already know Earth can fail us, or we can fail Earth. We imagine domes because we can no longer quite imagine forever trusting the open sky. You step back, looking out across a landscape dotted with bubbles of light, scattered like pearls across a dark surface. Each dome holds its own climate, its own society, its own fragile continuation of life. The planet outside still spins, still endures, but for humans, survival has become conditional, engineered, sealed. You lie down within the dome, staring up through the translucent ceiling. Beyond it, stars twinkle, distorted slightly by the glass. For now, you are safe, shielded from the chaos outside. But the dome is not Earth. It is a reminder that when habitability slips away, survival doesn't end instantly. It contracts, narrows, and walls itself in. You step out of the domed city, only to find yourself looking upward again, not at protective glass this time, but at the wider cosmos, the infinite backdrop against which Earth has always played out its drama. The thought comes quickly, almost instinctively. If this planet falters, maybe the solution isn't to hide under domes or spray the sky with aerosols. Maybe the solution is to leave. You stand on a bluff under the stars, watching rockets blaze upward, and you feel the mix of awe and desperation in that fiery trail. This is humanity's boldest dream, escaping Earth and finding another home among the stars. Your mind drifts first to Mars, the red planet, neighbour, and obsession. It's small, dry and frigid, with an atmosphere so thin you'd suffocate before you could finish saying, well, this was a mistake. And yet, it's the most realistic option nearby. Scientists envision terraforming it, thickening the atmosphere by releasing greenhouse gases, melting its frozen CO2 caps and warming the planet enough for liquid water. You picture sprawling greenhouses dotting the Martian surface, domes like crystal seeds pushing back against the red dust. It sounds exciting, but also exhausting. Historians still argue whether terraforming Mars is truly feasible, or just a romantic metaphor for human stubbornness. The physics may allow it, the logistics may not. A quirky fact: Mars once had rivers, lakes, maybe even an ocean. Evidence lies in dried deltas and minerals that form only in liquid water. Billions of years ago, Mars might have looked like Earth, alive with possibility. Then it lost its magnetic field, its atmosphere was stripped away, and its surface became sterile. Walking there now is like walking through a warning. This is what happens when habitability slips and never returns. From Mars, your gaze swings further, to icy moons like Europa and Enceladus. Beneath their frozen crusts lie hidden oceans, warmed by tidal flexing. Submarines may one day swim those alien waters, hunting for microbes that never saw the sun. It's an eerie but hopeful vision, life clinging to a place so unlike Earth. If microbes thrive there, maybe humanity could build habitats nearby, tapping those oceans for survival. The thought that water, that ancient companion of life, might await you under alien ice feels strangely reassuring, but the ambition doesn't stop at moons. Scientists now catalogue thousands of exoplanets, worlds orbiting distant stars. Some lie in their stars' habitable zones where liquid water could exist. Names like Kepler 186f or Proxima Centauri b sound more like license plates than homes, but they spark imagination nonetheless. You imagine stepping onto a rocky alien shore, staring at skies coloured by unfamiliar suns. Historians still argue whether any of these Earth-like worlds are truly hospitable, or whether the term is just a hopeful stretch. From dozens of light years away, habitability is more a guess than a guarantee. The scale of the challenge looms. Even Proxima Centauri b, the closest potentially habitable exoplanet, is over 4 light years away. With current technology, it would take tens of thousands of years to reach. That's longer than all of recorded human history. Quirky tidbit. Scientists have proposed generation ships, massive vessels where entire communities would live, reproduce and die, while travelling through space, their descendants arriving at the destination. Imagine explaining to your children that their great-great-great-great-grandchildren might see the new world. But you never will. A bedtime story that doubles as a family tree, and yet rockets still roar. Humans still dream of colonies beyond Earth. You realise it's not just practicality, it's psychology. To imagine escape is to imagine hope. Earth may falter, but the stars whisper alternatives. Domes on Mars, floating cities on Venus's cloud tops, space stations orbiting distant worlds. Each vision is fragile, improbable, maybe even absurd, but it feeds the human refusal to accept endings. Still, you can't ignore the irony. Humanity has yet to fully manage one planet, yet dreams of terraforming another. It's like burning down your house and deciding the solution is to build a mansion on the neighbour's lawn. Historians still debate whether the drive to leave Earth is visionary or escapist, genius or folly. Perhaps it is both. You sit at the edge of a launch pad watching another rocket tear upward. The ground shakes, fire roars, and for a brief moment you feel the pull of possibility. Beyond the smoke, the sky opens, vast and indifferent. Will humans ever truly leave Earth behind, settling elsewhere? Or will this always remain more dream than destination? No one knows. For now, though, the launches continue, streaks of light against the night. Each ascent is a mixture of engineering and prayer, ambition and desperation. The dream of leaving is alive, even if the execution remains uncertain. Earth spins below you, fragile but still habitable, for now. The stars call, but the home you stand on is still the only one that answers. The rockets fade into the dark, leaving silence again, and in that quiet your gaze drifts downward, past cities, past deserts, past forests, to the hidden corners where life clings with quiet tenacity. For all the grandeur of human ambition, you realise the most likely survivors of a collapsing Earth won't be astronauts boarding rockets, but microbes burrowed deep underground, or bacteria drifting in briny pockets beneath the seafloor. Life, after all, doesn't need to be large, clever or poetic to endure. It just needs to be stubborn. You crouch at the edge of a hot spring, steam curling into the night. Within its scalding waters, microbes thrive at temperatures that would cook most animals alive. These extremophils, lovers of extremes, remind you that habitability is a relative concept. What's deadly for humans can be paradise for them. When Earth grows too hot, too acidic, too irradiated, it may simply be an eviction notice for complex organisms, not for life itself. A quirky fact: microbes have been discovered kilometres underground, feeding not on sunlight but on hydrogen released from rock. Entire ecosystems sealed away from the surface, humming along as though the outside world doesn't matter at all. You descend into one of those underground realms guided by flickering lamps. The air smells of minerals and damp stone. Pools of water gleam in the darkness, each hosting invisible colonies of bacteria that could outlast empires. Some of these organisms divide only once every 1,000 years, patient beyond comprehension. They make human lifespans look like brief sparks. You realise with a shiver that even if Earth's surface boiled dry, these microbes might never notice. Their world would remain, hidden, humming, indifferent. Historians still argue whether early life began in deep-sea hydrothermal vents or in shallow pools kissed by sunlight. But what matters tonight is that life can exist without sunlit forests, without breathable air, without gentle climates. If Earth becomes uninhabitable for humans, the planet itself will probably still pulse with microbial resilience. In fact, Earth's history suggests microbes are the baseline, and complex life like you is the experiment. When conditions shift, the experiment ends, but the baseline remains. You wander further and find tardigrades, tiny water bears, waddling under a microscope lens. They look almost comical, like plush toys with 8 legs, but they are among the toughest creatures alive. Tardigrades can survive extreme heat, cold, radiation, even the vacuum of space. They can dry out completely, enter a suspended state, and reawaken decades later when water returns. A quirky tidbit. In 2007, scientists exposed tardigrades to open space outside a spacecraft, and many survived. If humanity disappears, it's not hard to imagine these microscopic bears carrying the torch of life. Picture a distant future where oceans vanish, continents bake, and skies turn toxic. On the surface, silence reigns. Yet miles beneath, bacteria continue dividing, tardigrades continue rehydrating, and extremophils continue their chemical feasts. Earth may be uninhabitable for complex organisms, but not for them. In this vision, the last survivors aren't humans, aren't mammals, not even insects. They're microbes, invisible yet eternal. You pause on the seafloor beside a black smoke event gushing superheated water. Here, in absolute darkness, tube worms sway, nourished not by photosynthesis but by chemosynthetic bacteria living inside them. It's an alien ecosystem already, proof that sunlight isn't essential. If the surface burns, these vents may continue for millions of years, little pockets of habitability in a hostile world. You wonder whether, long after humans vanish, Earth might still look alive from a microbial perspective, its skin scorched, but its gut still teeming. And here's a thought. Perhaps habitability isn't about comfort at all. For microbes, acid baths, crushing pressures, and toxic chemicals are home. To them, Earth will never truly be uninhabitable. It will only shift from one set of niches to another. Humans define habitability by whether humans can live here. Microbes define it by whether something can persist. By that standard, Earth may never truly die until the sun itself strips it bare. Historians still debate whether life, if driven underground, could ever re-emerge if conditions improved. Would bacteria one day crawl back up, evolve again into forests, fish, and philosophers? Or would the age of complexity be a one-time experiment, never repeated? The answer remains hidden in time, like so much else. But the question itself gives you perspective. Earth's story isn't about you, not really. It's about survival in whatever form it takes. You sit on a rock ledge in this imagined future, surrounded by heat, minerals, and the quiet persistence of microbes. They don't sing, they don't build, they don't dream. They simply exist patiently, enduring every catastrophe with the calm of eternity. Compared to them, human worries seem almost theatrical. Yet maybe that's the point. You aren't built to endure forever. You're built to burn brightly for a moment, then pass the torch back to life's simpler, sturdier forms. The last survivors of Earth may never know you existed. They may never evolve into something more. Or perhaps they will, given enough time, billions of years from now. Either way, the continuity is there. Life doesn't end. It only changes costume, downshifts into forms that laugh at your fragility. That knowledge is strangely calming. When you fall asleep tonight, microbes will still hum in the dark, carrying the planet's story forward in silence. The underground caverns of microbes fade from view, and you drift outward, higher and higher, until Earth itself lies before you in the cosmic dark. From here, the planet looks serene, but you know better. You've walked through quakes and floods, stared at boiling skies, felt radiation bite the skin. You've imagined continents colliding, atmospheres collapsing, seas vanishing. Now you stand at the edge of time, gazing at the far future when Earth itself becomes uninhabitable, when its story as a living world is finished. It's not a question of if, it's a question of when. You look ahead billions of years. The sun, swollen into a red giant, has boiled away the oceans. Mountains crumble under relentless heat. Volcanoes sputter in vain. Earth's crust bakes, glows, and fractures. What was once a mosaic of green and blue is now rust-red stone, cracked and lifeless. The magnetic field has sputtered out. The atmosphere is gone, ripped away by solar winds. The planet is silent, empty, bare. It spins still, but as a monument rather than a home. From the moon, the sight is haunting. Earth no longer shines with oceans and clouds. It is just rock, glowing faintly under a swollen sun. Historians still argue whether its final act will be total engulfment by the sun's outer layers or a slow orbital retreat, scorched but intact. Either way, the Earth you know is gone, and yet you realise this isn't tragedy so much as inevitability. All planets, all stars, all systems have lifespans. The miracle wasn't that Earth lasted forever. The miracle was that it lasted long enough for life to emerge, to flourish, to wonder about its own future. You, sitting here now, are part of that miracle. You exist in the brief golden window between chaos and silence. A quirky detail comes to mind. Astronomers scanning the galaxy often search for biosignatures, chemical traces that suggest life on distant planets. Someday, when Earth is long dead, light from its past may still carry those signatures across space. Aliens peering through telescopes might catch whispers of oxygen, carbon dioxide, and water in Earth's spectrum, not realizing they're looking at echoes of a long-vanished biosphere. In that way, Earth may still introduce itself long after it has gone silent. You drift even further into the future. The sun, after its red giant phase, sheds its outer layers, leaving behind a white dwarf, small, dense, glowing faintly. Around it, Earth's corpse continues orbiting, perhaps shattered, perhaps whole, but lifeless either way. The night sky, once lit by a golden star, is now illuminated only by a dim ember. It is both melancholy and oddly beautiful, like a candle's last flicker. But endings are never only endings. The atoms that once made up oceans and forests are scattered, recycled into new forms. The carbon that once formed trees, the iron that once built skyscrapers, the calcium that once shaped your bones. They may drift into space, joining dust clouds that one day birth new stars, new planets, new chances. Earth as you know it ends, but Earth as material continues. You're part of a cycle so vast it dwarfs even extinction. Historians still argue whether humanity will make it far enough to watch Earth's last days, or whether your story will end much sooner. Maybe humans colonize Mars, settle among the stars, and one day look back at Earth as a childhood home long abandoned. Or maybe you vanish quietly, leaving only microbes to linger until the end. The specifics are unknowable. What's certain is that Earth itself will not last. No world does. You sit in orbit staring down at the future barren rock and feel a wave of calm. You've walked through every possible ending, tectonic shifts, greenhouse spirals, magnetic collapse, cosmic collisions, stellar death. Each path leads to the same truth, that Earth is temporary, and instead of despair, the knowledge feels strangely freeing. Temporary doesn't mean meaningless. Temporary means precious. The very fact that Earth is habitable right now, for you, is a cosmic jackpot against staggering odds. So you let yourself relax. You picture the ocean still shimmering today, the forest still breathing, the city still humming with light. You think of the microbes hidden below, the stars shining above, and the quiet rhythm of a planet still alive. Someday Earth will be silent, but tonight it still whispers, it still cradles, it still gives you air to breathe and ground stand on. The lights dim around you, the hum of the world softens, and your eyelids grow heavy. You let the thought of Earth's long future drift further and further away, like a ship vanishing into mist. The planet spins on, fragile but alive, temporary but luminous, and with that you slip towards sleep, carrying with you the simple truth. Earth won't last forever, but tonight it still belongs to you.